coming out. My name is Blake Waters. I head up engineering on the SDKs and APIs at Layer. And today I'm here to share Atlas, our library of open source messaging UI components with you. So from an agenda standpoint, first I wanted to do a brief overview of Layer and tell you a little bit about what we're trying to get done. Then do a high-level overview of LayerKit, our iOS SDK. And then walk through do an intro and exploration of the Atlas UI components themselves. Then we'll wrap it up with a quick demo of Atlas Messenger, our open source sample app, and then take questions and we can get into some code if you guys are interested. So first we want to talk about Layer. So at Layer, our mission is to facilitate the transition from traditional telephony infrastructure onto the internet. We view Layer as one product where we're producing a pure IP communication stack for the internet. We currently provide rich async messaging, but eventually we'll deliver synchronous voice and video calling and related communication services. We see Layer as an integrated stack of complementary technologies and services. We provide infrastructure, backend services, client SDKs, and UI components that enable you to add communications to any application. We're currently offering native SDKs on iOS and Android, and have web APIs and a JavaScript SDK available in early access. We view Layer as a building block. Much like maps and payments, developers don't expect to implement building blocks themselves and instead seek out well-crafted solutions. You look to companies like Google or Stripe to provide these services. We think communications is another fundamental application building block, and Layer is the company you should turn to when you need it. So now I want to take a quick look at LayerKit, the Layer SDK for iOS. LayerKit's the underlying technology for Atlas, so it's important to have some context on it before we dive into the UI components. So what does LayerKit provide? LayerKit provides small group conversations. Our conversations can currently have up to 25 participants. The participant list is mutable, so you can add and remove people from those conversations. And you can have multiple conversations with the same group of people, whatever makes sense for your application. In a message, you can send multi-part messages where each part can be up to 2 gigabytes in size. Each part has a developer-assigned MIME type and is treated by Layer as an opaque data blob. Message parts less than 2K in size are inlined into the message itself and are delivered directly to clients, while larger parts can be downloaded on demand. We also include support for typing indicators, delivery and read receipts, mutable metadata, and user blocking. These are the sorts of advanced features that users have come to expect, so we provide first-party support for all of them. Next, Layer is implemented using a sync-based programming model with offline support, change notifications, and live object references. The core of the Layer SDKs is an object synchronization engine. Changes that are made in the local data store are transparently synchronized as quickly as possible. We maintain a local cache of all the conversations and messages so that they are available in offline scenarios. This data is accessible to you via a rich query model, and LayerKit maintains a persistent connection to the server that receives pushed events as content changes, so you discover changes very quickly. Next, we do deep integration with iOS technologies, in particular Apple's push notification service and the background transfer service. Messages can optionally trigger push notifications that include alerts, sounds, and update the application badge count. We use the content available flag so that pushes can trigger background synchronization. We're also integrated with the background transfer service so that we can upload and download those large message parts when the app is not in the foreground. Now I want to go over a little bit of the design philosophy behind the Layer SDKs. The first thing is we focus on delivering engineering leverage so you can focus on your user experience. Developers pick building blocks because they speed your time to market and allow you to access higher levels of quality and functionality by reusing the work of others. Next, we try to insulate developers from concerns such as offline state, transient network failures, and recoverable errors. We think developers prefer simple models that abstract away underlying details. We take care of the low-level items such as security and connection state management so you don't have to think about it. Next, we try to integrate neatly with the host application in the platform. Layer addresses communications in your user namespace, delegates authentication to your backend application, and tightly integrates with iOS and Android platform services such as APNS and GCM. We work hard to make sure that the SDKs feel at home on the platforms and conform to the language idioms. All the code should feel natural and familiar to you. Last, we work hard to strike a balance between flexibility and simplicity in the APIs. Since we're focused specifically on communications rather than building a general purpose database in the cloud or delivering a real-time data transport solution, we can build APIs that have very specific semantics. Concepts like delivery receipts and read receipts are first-class citizens rather than being something you can implement on top of our APIs. We try to balance this simplicity with enough configurability and expressiveness so you can implement any communications experience in your app. Now I want to get into the specifics of Atlas, which is the UI components that sit on top of LayerKit. So what is Atlas? Atlas provides a library of open source UI components that provide you with in-app communications experiences. It builds on top of the public layer SDKs to highlight how UIs can be constructed. We developed and delivered Atlas as a separate project from our core SDKs because it just represents one view of how you could implement UIs on top of Layer. There are others. Last, we try to deliver both full UI controller experiences that you can just snap in and immediately experience joy from, and the low-level view components that those experiences are built from. We try to give you enough stuff that's turnkey, but then you can pick up the nuts and bolts that we've built from and use them yourself. So next, I want to go through the design goals of Atlas. So first, we try to deliver good-looking, high-quality implementations of familiar messaging experiences out of the box. On iOS, Atlas is styled much to look like iMessage, as it's the most familiar messaging experience that every iOS user has. Next, we try to give you enough, enable quick and easy branding of the user experience so that you can blend those components to match your style. On iOS, this means we are integrated with Apple's UI appearance and interface builder APIs. So all the fonts, colors, weights, all that kind of stuff can be customized in just a few lines of code. So this lets you take Atlas, add it to an existing application, and match the style with just a few lines of code. Last, we support full customization by letting you ignore our views and snap in your own components. If our theming capabilities aren't enough to satisfy your design, you can still leverage all the scaffolding that Atlas provides to efficiently get the conversations and messages out of the data store and feed them to the UI, but replace all of our views with your own. Now I want to walk through the components that ship with Atlas. We'll take a look at several of the controller experiences and then discuss how Atlas supports content objects and UI customization. So this is a trio of screenshots that we'll walk through. The first component is the conversation list. This should look very familiar to anybody that's used iMessage before. The conversation list provides you with an auto-updating list of conversations. LayerKit provides a query controller that provides live updates to the UI as objects change from the synchronization engine. The conversation list here utilizes one of these query controllers to display a list of conversations that's ordered by the last time that a message was received. This list is searchable by participants. You can tap into that search bar, start typing the name of a participant, and quickly filter that list to show your conversations with that person. You can optionally display user avatars on the screen, so it's not enabled in the screenshot that's on the screen, but Atlas includes a little view that will render the initials of the participant who sent a message, and they'll just draw on the left-hand side of the screen. Last, we support swipe to delete on conversations, so you can enable a couple of deletion modes to just swipe from the right-hand edge of that cell and then delete the conversation. Next, we're going to take a look at the conversation view. This is the main view controller that users are going to interact with when using Atlas. So this controller displays a collection view of messages inside a conversation. This is also using one of the LayerKit query controllers to display the content. The query controller supports pagination in the result set, and we're leveraging that here to efficiently display a subset of the messages in an arbitrarily large conversation. So if you have a conversation with 5,000 messages in it, it's probably not useful to have all 5,000 there. We'll load a page of like 50, and then as you scroll up, efficiently load some more, and you can just keep on going back into history. Next, we currently support text, image, and location content. We'll talk a little bit about this in a minute when we get to the content objects. Next, it has integrated support for delivery and read receipts and typing indicators. Modern messaging apps like Facebook Messenger and WhatsApp have trained users to expect these kind of features, so we just bake the support right in. Last, the controller is very customizable. All the basics like how the dates are displayed, what the avatars look like, and then even the cells. You can plug in a couple of delegate or data source messages and then tweak the layout to achieve the effect that you want. Next, this is the conversation detail screen. This is actually not in the Atlas library itself right now. It's part of our Messenger example app, but we may migrate it into Atlas. This lets you configure the details of a particular conversation. It currently supports assignment of a conversation name via metadata. Conversations can include arbitrary key value pairs that you can kind of anchor additional data onto the conversation. We've used that support here to implement conversation naming. So if you give a name to a conversation, like my conversation here, then when that draws on the conversation list, you'll see that name instead of the list of participant names. You can also add, remove, and block participants from this screen. And the little red button at the bottom will allow you to delete or leave the conversation. Next, we include support for a participant picker. So this is a pretty basic table view, but it's something that almost any application that's going to have messaging is going to need, so we provided it. It includes a support for a searchable list of participants. So in the screenshot here, I've started typing Steve's name, and it's filtered the list down. The sorting is configurable, and it optionally supports multiple selection. So if you want to start a conversation with 4 people, you can quickly select them there and then commit them all at once. It can also display which users have been blocked if you're leveraging the block feature. So next, we'll talk a little bit about content objects. So on the left here, you'll notice that the text input field includes a picture that was just taken or picked from the photo library. The text field has expanded to wrap around that image, and if you hit send, it'll take that image and the text that's in there and turn it into a single multi-part message that contains the image and the text as separate parts. Then on the screenshot on the right, you can see that we've shared a location, and it's rendered as a map view. You'll also notice the send button includes a little location arrow instead of send. So if you haven't inputted any text, by default, Atlas will let you share a location just by tapping that button. You'll also notice that in that screenshot, there's a read receipt that's being displayed, or the message has been read by one participant, and you'll see that John is typing, and a typing indicator has been displayed along the bottom of the view. We're going to be expanding this functionality and let you embed and share additional content types in upcoming releases of Atlas. So the last thing I wanted to touch on is the support for customization in Atlas. In this screenshot, I'm showing you 3 views of the same conversation where we've just changed out the background colors, the fonts, and the text colors. This is the kind of theming that's really easy with the appearance proxy. Okay, cool. Well, thanks for having me over to share Atlas with you.